Chemical reactions and equations. Chemical equations. Chemical equations are the symbolic representation of chemical reactions. These are the simplest forms of representing a chemical reaction. For example, let us consider burning of magnesium ribbon in air. That is, when magnesium ribbon burns and reacts with oxygen in air, it forms magnesium oxide. Let us perform an experiment to know more about what happens when magnesium ribbon burns in air. Magnesium burns with a dazzling flame to form magnesium oxide, which is the white powder. Writing a reaction is a long process, so we represent it by word equation. That is, magnesium plus oxygen gives rise to magnesium oxide. The substances that undergo chemical change in the reaction are called reactants. That is, magnesium plus oxygen are reactants. The new substance that is formed during the reaction are called product, that is, are magnesium oxide. Reactants are written on LHS. Products are written on RHS. The arrow mark represents the flow of the reaction. From the following observations, we can know a chemical reaction has taken place or not. That is, whenever there is change in state, we can say a chemical reaction has taken place. Or whenever there is change in color. Or in a reaction, when an evolution of gas occurs, we can say a chemical reaction has taken place. For example, when ENO is added to the cold water, there is evolution of gas. Therefore, we can say a chemical reaction has taken place. Change in temperature. For example, when an ice cube is kept at room temperature, there is change in temperature and the ice cube melts, changing its state. Thereby, we can say a chemical reaction has taken place. Writing a chemical equation. From the previous example, we know that magnesium plus oxygen gives rise to magnesium oxide. That can be represented as magnesium Mg, oxygen O2 gives rise to magnesium oxide, that is MgO. The number of atoms in reactants are not equal to the number of atoms in the product. Such chemical reactions are called skeletal chemical equations. That is, here we have in the reactants the number of magnesium atoms are 1, oxygen it's 2, and in product the number of magnesium atoms are 1 and oxygen is also 1, where the equation is not balanced. It is very much necessary for us to balance a chemical equation because from our earlier chapters we have learned the law of conservation of mass, which says mass can neither be created nor be destroyed in a chemical reaction. That is, total number of elements present in the reactants has to be equal to the total mass of the elements present in the products. According to our previous example, the equation is unbalanced. So, how do we balance a chemical equation? Step 1. We have to write each element in boxes to represent that we are balancing a chemical equation. In step 2, we are creating a table to list the number of elements present in the chemical equation. As we know, according to the equation, we got magnesium plus oxygen gives rise to magnesium oxide. In the reactants, we have got one magnesium atom, and in product, we have got one magnesium atom. In this equation, we can say magnesium is balanced. But how about oxygen? In reactants, oxygen atoms are 2, and in product, oxygen atom is 1. So, oxygen atoms are not balanced. Thereby, step 3 is balance the compound that contains the maximum number of atoms. Thereby, from our previous equation or the previous table, we are considering oxygen atom. That is, according to this equation, initially oxygen has 2 atoms, and in product oxygen has 1 atom. To balance this equation, we are multiplying 2 in the product. Thereby, our equation becomes Mg plus O2 gives rise to 2MgO, because we have multiplied 2 in the product to balance the oxygen atoms. Now let us see whether the equation is balanced. Magnesium in reactants is 1. Oxygen in reactants is 2. In product, number of atoms of magnesium has become 2. Number of atoms of oxygen has become 2. Thereby here we have balanced oxygen atoms, but now our magnesium atoms are unbalanced. So, in our next step, we are considering magnesium atoms. That is, according to our previous equation, we have got Mg plus O2 gives rise to 2MgO. Thereby, the initial number of atoms of magnesium is 1. In product, it is 2. Therefore, to balance, we are multiplying magnesium atoms twice in reactants. Therefore, our equation would be 2Mg plus O2 gives rise to 2MgO. Is our equation balanced now? Let us check. Number of atoms of magnesium in reactants is 2. Oxygen is 2. And in product, number of magnesium atoms are 2. Oxygen is 2. Thereby, according to the law of conservation of mass, our equation is balanced. And this method of balancing the chemical equations are called hit and trial method.